sponsored by PCBWay.
Hey, it's me, your friendly neighborhood fake Spider-Man, who doesn't have superpowers, can't stop crime, and isn't funny. But what I can do is shoot webs and swing from them. Yeah, this is the web shooter I made 2 years ago, and it's really cool. It's so... I forgot I was upside down. Okay, so guess I'm gonna have to build a new one. Maybe that's not such a bad thing though, because admittedly there were some design flaws in the original. It was too large, and it didn't really look anything like the real Spider-Man's web shooters. So that's my goal. Make the web shooters smaller, wrist-mounted, and prettier. The only problem is, they have to do all these things and still be strong enough to swing from. By the way, I actually did hang upside down off the side of a building to get that intro, so I hope you appreciated that. But yeah, I'll be pretty much overhauling my old web shooters entirely. If you want to see how they worked, I have a whole video about them. But the important thing to know is just that my old web shooters were kind of like metal cylinders that shot one web each, and then you could hold onto like a handle to swing from. They launched the webs with an explosive mix of compressed propane and air, which is pretty dangerous, but more annoyingly, the flame front actually melted my webs over time. So for the new launcher, I'm going to start from scratch and use compressed air. But I'm not talking about normal compressed air, like 120 psi, or even those CO2 canisters that you see all the YouTube makers use, myself included. Those are a lot better at 800 psi, but they still kind of suck. Their aperture is too small to dump the gas quickly, and liquid CO2 at room temperature just takes a while to vaporize, so you're not really getting the full power that that pressure should offer. No, I'm talking about air at like 4,000 psi, which is the kind of pressure that puts scuba tanks clean through brick walls. I reckon with this kind of pressure, I can get the launcher down to like the size of a wine cork. But to my knowledge, a tiny valve that can hold that kind of pressure and open that quickly and have an aperture that size just straight up doesn't exist and never has. So I'm gonna have to design it myself. And I came up with this, a custom valve that can do all those things. To save space, there's no separate air chamber. The valve itself holds all the air that it needs. You basically pressurize it through a one-way fill port here, and the air is trapped by these extra hard O-rings on either side of the spool. This spool in the middle can freely slide backwards and forwards, and the whole thing activates when you pull the spool far enough backwards. At the moment where the front seal leaves its housing, all the air can begin rushing out through these slots, and in fact the pressure differential now helps to push the valve core the rest of the way open, which is known as a blow-open design. Now I want to stress, I'm not building a pipe bomb, it just might be one by accident, if my calculations are wrong. 4,000 psi in metric is about 260 bar, which, you know, metric being an actually sensible system, just means there's 260 times as much air squashed into there than it would probably prefer. And yes, if you're feeling pedantic, that's only for the isothermal case, but come on, let's not be thermodynamic snobs here, okay? Other than the fill port, everything is custom made, so I started machining. Everything needs to be pretty hefty so it doesn't explode, but it also needs to be very precise, because if there's a gap at these pressures, the O-ring will basically just liquefy and squeeze itself out of the gap. Sadly, I don't have a milling machine, so after a bunch of high precision turning, I just had to take an angle grinder to the valve core to make the airflow slots. Then I drilled through the tail of the core and made a tiny lever that acts as the trigger. Finally, I assembled the whole thing and welded on the fill valve and the end caps. So yeah, this is the finished valve. Open, closed, open, closed. I did a quick high pressure test to confirm that it was in fact a valve and not an IED, but it didn't explode, so success. Before I even attach the barrel though, let's first just see how much air comes out of this thing when you fire. Goodness gracious! Whoa, that is a lot more vicious than I expected. I was feeling pretty good about this, but before I could stick a barrel on it, I needed to know what shape and size the new web is going to be. So let's put a pause on this and go have a think about the web. So, to quickly get you up to speed, when I was first looking into making real Spider-Man webs, I did some polymer extrusion tests, but quickly realized that despite some really cool liquid spiderweb demonstrations on YouTube, if you want to safely hold a swinging person on a thin web, you just gotta use strong rope. But rope doesn't stick to things. So I invented something called a hook chain. It's a bit like a grappling hook, but it works by wrapping around something and fastening to itself. So it's much more reliable and it's way smaller. But for this new tiny web shooter, it's still not small enough. So I'll need to shrink the whole thing to about a quarter the size, like this plastic mock-up that I printed on a Ender 3S that Creality kindly gave me. The problem with making the hooks smaller is they will break. Unfortunately, even if they're made of steel, supporting the weight of a swinging person is just a lot. But I actually think the solution, much like burglary, is to level up my steel game, because the amount of variation in the strength of metals is so much more than most people expect. I want to show you a chart that's probably going to blow your mind. All right, yield strength of pure aluminium. 35 megapascals is not too good, but by alloying it with a few materials, you can get 60-63 structural aluminium. Noticeably better, but by heat treating it, you can get it all the way up to 150 megapascals. Huge improvement, but not as good as regular mild steel, which is 280 megapascals. But mild steel is not as strong as steel can get. Let's jump all the way up to tool steels. Yeah, so it is off the charts. I've pasted some paper to, let me show you. So yes, it definitely tops the charts and then goes higher into the ceiling even. Then keeps going. It goes all the way along the ceiling until here, 1,900. That is an awful lot more than 280. But it is a little bit brittle compared to normal steel, which is where this last material comes in. Have you ever heard of mar-aging steels? They've got all the strength of tool steels, but they're not as brittle. They have better impact resistance, and in fact they can be stronger than tool steels. They can go all the way across the whole ceiling to the wall and down the wall and keep going. 3,450 megapascals. Aluminium is 35. That's 100 times stronger. 100! I mean, these hooks, they're gonna be tiny as soon as I can get some more aging steel. So, it turns out, two of the most common uses for mar-aging steel are missile chassis and uranium enrichment centrifuges. And I also live in South Africa, which is a country that has some interesting foreign relations. So I'm not actually able to get any, unless I move to a really non-threatening country like Canada. International authorities love Canadians, right? So I did do that. I moved to Canada. The rent prices were pretty horrendous, and I had to convince a friend of mine to let me use his very nice workshop. But all in all, it was pretty straightforward. And that allowed me to contact an American supplier for mar-aging steel, which was very exciting up until they told me it'll be $4,000 and 6 weeks for a single piece. Which, you know, I probably should have checked before moving here. In the end, I figured I'd just try with tool steel and hope there's no impact issues. For a part like this, I could see an easy way and hard way of making it. The easy way was to get the metal 3D printed, but I didn't want to back down from a challenge. But I did. So I went online and ordered some hooks out of 3D printed tool steel from PCBWay. PCBWay has kindly sponsored this video, and they don't want to waste your time either, so let me give you the quick 20-second spiel on what they offer. They do circuit board fabrication, obviously, hence the name, up to 64 layers, rigid, flex, stencils, whatever, and assemble them. They can 3D print in fused nylon, stainless steel, tool steel, even titanium. They can do CNC machining, including full 5-axis milling. They can do sheet metal fab. They can do injection molding. All these processes from a single service is pretty neat. So if you need some prototyping done, give PCBWay a look at PCBWay.com. My hooks have arrived. They look great, but I'm gonna have to set up a tensile test to see if they actually meet my insane requirements. Because this tiny part needs to hold 300 kilos, or in American units, approximately 1 Harley-Davidson. I don't have a tensile tester, so I just stuck a crane scale on a whopping great ratchet strap and started hoisting. The test worked pretty well, and the 3D printed tool steel did way better than a stainless test piece I made, but sadly the hook broke before I got to my 300 kilogram goal. Tragically, that means I'm gonna have to do it the hard way. So I had the hooks laser cut from some, oh wait, laser hardens the edges. So I had the hooks water jet cut from some 440C tool steel, then made some jigs to CNC mill some curved faces so that the rope wouldn't be cut by the sharp edges of the hook. Wait, this is sharper now? Okay, so I fixed that with some more milling, then used a lathe and a plastic jar full of steel balls to tumble them, further knocking down any edges before taking them to another company for heat treating. And they're done! Several frustrating weeks for me, but hey, only 20 seconds for you. I tensile tested them and they survived 300 kilograms, no problem, thank goodness. But I wasn't sure about their shock resistance. I don't have a Sharpie impact tester, but there's a much easier way to check shock resistance. Yeah, that is what I thought would happen. To be fair, most people get quite shocked when you hit them with a hammer, so this result isn't too surprising. It'll probably be fine. To finish up the web, I needed to focus on the rope. One of the biggest issues with any rope is that when you tie a knot in it, you lose like 20 to 50% of its original strength. But in super thin high-performance Dyneema like I'm using, you lose like 85%. Of all the knots I tested, a triple fisherman's ended up performing the best, but it was still pretty appalling. So I had to turn to the mystical world of splicing. Essentially, splicing is working a rope's fibers back into itself to make a loop, or joining lines by kind of feeding them into each other.
and a splice can retain up to 100% of the rope's original strength. Depending on the braid angle, you can even splice thin and thick line together seamlessly, which is pretty cool. So yeah, now the webs can be made with thinner line. I spliced all the loops and painted the hooks white, and the webs were basically done. These are just the boring loop over beam webs, but I've got some more advanced ones I'm working on that I'm really looking forward to showing you next time. Now I knew the size of the webs, I could make the launcher's barrel to fit them. So I started welded some attachment posts onto the valve, made a rubber gasket, and welded up a small square barrel that would fit the web perfectly. While I was at it, I also had the idea to make this. A thin, round, long barrel that I could just stick a bit of metal in there and use it as a projectile to see what kind of power I had available. I set up a little bench test with my mate Jeff, but I wasn't really sure what to expect. I started at about 20% of max pressure. So this is the first shooting test at 900 psi, so let's give this a go.
What the heck? At 900? The flipping board. Goodness gracious.
Do we try 2000?
JT, I'm gonna be honest, that scared the absolute
2000 psi.
I did some preliminary maths, and it came out that it was going to be like a quarter the energy of a 9mm, and I was like, no, that's not right. I've done the maths wrong.
It sounded like a gun.
Yeah. Oh. So yeah, it's too powerful. I can run this thing at 1/10 and still worry about breaking my fingers when it's strapped onto my wrist. Speaking of which, I had to figure out how to mount this thing to my wrist. And I was seriously considering designing a black leather bracer like Tom Holland's Spider-Man uses, but in the end I just went with some simple low-profile Velcro straps to make it really easy to put on and take off. Of course, with the plain metal it looks kind of bad, so I needed to design a plastic casing for it. My mate Santiago agrees with me that the Andrew Garfield web shooters are the best looking, and he made this really cool 3D mock-up based on those using cardboard-aided design. Then I took it as a base and modelled a similar one with computer-aided design, and added this cool little spider motif along the whole piece. Then I 3D printed it in resin, hand painted on some detailing, and I was done. So this is the finished web shooter. To operate it, you first load a small piece of wadding to help the projectile seal, and then you load the web after it. Short webs can fit in the barrel by themselves, but for long webs you store the excess length in this cassette underneath. The web isn't attached to the launcher because you can't really hang your whole weight off Velcro wrist straps, and also because I'm currently working on a device to help your hand be able to grab onto the web safely, which is more like the real Spider-Man anyway. Oh yeah, and the web does hold my weight, no problem. To charge the launcher, you just plug the hose from a portable HPA tank into the web shooter's quick connect port, fill it, and then disconnect. This tank will refill the web shooter about 50 times if you're filling to max pressure, but because the launcher's way too powerful, I've typically been running it at like 15%. The trigger is just a thin loop that you pull to fire. In some of the movies he uses a button, but that would be so annoying. It would shoot whenever you try to grab something and would just get in the way. Putting the trigger loop over your finger does work, but you end up often doing T-Rex hands to try to avoid shooting accidentally. So the solution is a fairly loose line on your thumb that permits full motion, but can be actuated by grabbing the excess with the classic Spider-Man gesture. That pulls the trigger lever and fires the launcher. Oh no. No! No! Oh dear. Despite losing one of my webs there at the end, I am really pleased with this. Not only does it look great, but finally now I have webs and launchers small enough to consider putting multiple of them on one arm, which is like one of the main challenges to be able to swing continuously. Multi-shot will probably be 2 videos away though, because the next one's focusing on having webs that stick to more different kinds of objects and being able to securely grab onto the rope at any point by hand. That one will have some more action-packed testing. Sorry this was a bit light on that. Anyway, thanks for watching, and I'll see you in the next one.